Hey everyone, this is Mr. Figuet here. Today, in this video, we are going to talk about how we can calculate what we call sample proportions as well as the margin of error. So to this point prior to this video, we've talked a lot about how we can select a sample. And if I go back to the notes that we've already talked about, there were 5 main types of samples. And they each have their pros and cons. So you have your simple random sampling, which is probably the most straightforward way for us to sample a group of people. The convenient sample, which we've mentioned, those people who run up to you at the mall and ask you a question, what do you think about this or what do you think about that? That's convenient sampling, all right? They're just looking for people who come to them. Systematic sampling is also really nice. As we mentioned, exit polls, when you turn on CNN or MSNBC for the race for president or senator or anything like that, they use exit polls and they use systematic sampling for that. You have cluster sampling, which is semi-common, especially when you have groups of people that are in already made clusters. For example, students are separated into clusters of grades. So if we wanted to survey the students at Happer Horsham, as some of you mentioned in class discussions prior, you could just survey some from 9th, some from 10th, some from 11th, some from 12th, and that is cluster sampling. And then the last one is stratified sampling, which is a little more complex, but the main idea is we're going to specifically put students into clusters of a particular demographic that we want to analyze. Maybe we want to look at opinions of students, but we want to look at them in groups by gender, or we want to look at them by their ethnicity, race, or other types of what we call strata. And this idea is allowing us to be able to be a little bit more down the middle here. So one of the things that we didn't talk about in terms of the style of sampling is how many should you sample? Because the two biggest ideas when you're trying to make a sample is how are you going to sample and how many are you going to sample? So yesterday's lesson talked a lot about that. And in this video, we are going to move our direction to how many you should sample. And the way that we're going to look at that is we're going to talk about sample proportion and margin of error. So sample proportion is an idea that based on what you've already sampled, what percentage of the sample said yes, or maybe no if you're looking at a negative of people are, not wanting to do something. So in the situation here, in this example in our notes, it says out of 200 people surveyed, 60 of them said Doritos are their favorite chips. So when you want to find a sample proportion, this is a notation you'll typically sometimes come across, this P with a little, I don't know, I want to call it a tilde, but a symbol above it like that. Don't worry about that too much, but here's what you mainly want to be able to tell. What you want to do is create a percentage that in the numerator is the number of favorable outcomes over the total number surveyed. So in this situation, since we have 60 people who have selected Doritos as their favorite chips, that's the favorable outcome I want to analyze, and I want to look at the total of 200 people. And so what I'm going to be able to do is I can throw that in my calculator to get a percentage. So 60 divided by 200, and that's going to give me 0.3. Well, you can't see that. Sorry, there you go, 0.3. So 0.3, and as a percentage, that means you're just going to move it over to the decimal over right 2 places, and that's going to allow me to get 30%. You could also take a percentage or a decimal, multiply it by 100 to turn it into a percentage. So we now know 30% of people surveyed Doritos. Now here's the question. Is that number, how accurate is that number versus if I survey the entire school? And I didn't mention in this problem what the population was, but let's say the population is all students at Happer Horsham High School, or maybe all students in, not even students, maybe all people in Montgomery County or all people in Pennsylvania. How accurate is this 30% if I were to survey now 2,000 people? Well, what we have here is the margin of error. So it says how far off your percentage could your inference be? So there's a lot of different formulas for this, and if you end up taking a specific course about statistics, there are some additional metrics that we have to consider in this. But all in all, the most simple way to calculate margin of error is this formula that's listed right here. You're going to take the n value, which is the total number surveyed, and you're going to go 1 divided by the square root of that total number. So 1 divided by the square root of that total number in this problem would be 1 over the square root of 200. Let's go to our calculator, which you now can see officially. 1 divided by the square root of 200. And we get 0.07. 0.07. So that is the equivalent of 7%. Remember, I can multiply that by 100. So our margin of error is 7%. What that is saying is that most likely my answer is within 7% of the number 30%. And so the last question here is, in finding the interval most likely to contain the true population, you're going to take that proportion, that sample proportion of 30%, and we're going to add and subtract 7% from it to get our upper bound and our lower bound of what the answer should actually be. So what that means is if I were to survey the entire population, the margin of error tells me that the actual answer lies somewhere between 23 and 37%. Clearly, the more people you survey, the smaller the margin of error is going to become, which then builds your confidence level that what you've actually surveyed is fairly accurate. Okay? So that's it. That's the sample proportion, margin of error, and finding the interval. Let's look at a few examples for the last part of this video and see how we do. So in this problem, it says 800 students, that's going to be our N, that's the number surveyed, at a random college were asked if they own a laptop. 584 responded yes to the survey. So this is that X value that I was looking at in the last problem. So to find our sample proportion, what I'm going to do is simply take X divided by N, or the number of favorable outcomes divided by the total number. So in this case, I get 584 divided by 800. And to help me with that percentage, let's go ahead and throw that in the trusted calculator here. 584 divided by 800 gives me 0.73. As a percentage, we know that that is going to be 73%. So 73% of students responded yes that they owned a laptop. Based on this survey, though, what was our margin of error? So our margin of error here is going to be 1 over the square root of N, remember. And to find that margin of error, N here was 800. So 1 divided by the square root of 800. This is clearly going to be a better approximation than the Dorito problem that we just got done doing. So 1 divided by 800 is going to give me 0.035. Now, how far do you need to write these? I would say 0.035. Because that's a 5, I'm probably going to go ahead and round that to just 0.04. So round it to the nearest percentage, okay? Round it to the nearest percentage. So in this case, the margin of error is 4%. What is the interval likely to contain the true population? So essentially, we're going to take the number 73. We're going to add and subtract 4 to it to get that upper and lower bound. So this would take me from a low of 69% that would have Met laptops to a high of 77% that would own laptops. Feel free to pause and rewind if you need to go back to any of these examples, okay? All right, moving to the next question here. Of the 1,200 people who voted on a student election, in this case, I gave you a percentage instead. 63% of them voted Sarah for president. How many people actually voted for Sarah? So in this sample proportion formula that we came up with, remember that in the last two problems, we've taken the number of people divided by the total number surveyed, and we got a percentage. But in this situation, they gave us a percentage, which we're, of course, going to have to write that as a decimal in order to calculate it. But there it is. And then 1,200 people is going to be our N value. So that means in this case, we actually want to figure out what this X is going to be. How many people voted for Sarah? Now, there's a much easier way to do this. If you have a total, okay, which in this case is 1,200, and you multiply it by the percentage of, that is going to give you the number of people, okay, the number of people in this case. So we can actually just take the number 1,200, multiply it by 0.63, which is the decimal version of 63%. So we're going to take that 1,200, multiply it by 0.63, and we've got a winner of 756 people voted for Sarah. 756 people voted for Sarah, okay? And what I'm going to have you now try here, pause the video if you can, please try parts B, C, and D based on what we've talked about, and let's see what you come up with. All right, so as we look at this here are answers for part B, C, and D. Part B, we just using the margin of error formula. Part C, we add or subtract that 3% to the 63% we were given in the beginning of the problem. Part D is interesting because it says, should Sarah be concerned about winning? Why or why not? She shouldn't be. Because in order to win the popular vote, you need to have more than 50% who have voted for you. In this situation, because the survey was 63% and the margin of error gives us a lowest value of 60, she's pretty much guaranteed to win based on the calculations we made. This is exactly if you turn on the TV for any presidential government or governor, any government election, honestly, and you turn on stations like CNN and they say, we've projected that so-and-so candidate has won the state of Pennsylvania or has won the state of Iowa. That is done through exit polling, and it is done through analyzing a margin of error. And if that margin of error gives us this type of confidence, that's how these TV stations are able to make these projections well before all of the votes are actually counted. So it is a prediction at the end of the day, but it gives you some confidence here. So last example in this video, we're going to look at a different way. In this problem, it says the margin of error for a sample is 2.5%. How many people are in the sample? So our sample here, in order to figure this out, we have to figure out what our value of n is here, because the formula for margin of error is 1 over square root of n. We know that this is going to equal 0.025. And remember, that's just a reminder that 2.5% is just being divided by 100 to get that number. So what we're looking at here on the screen is the formula that we actually want to do. Now, there's a couple different ways in terms of helping us to solve this equation, but probably what I think will be easiest for us is to make this a fraction over 1 and then use cross multiplication to help us find our result. So this is going to be 0.025 square root of n equals 1. And in order to solve this, we have to get n by itself. The first step would be to take that 0.025 and move it to the other side. So now we would just have the square root of n on this side. And let's see, 1 divided by 0.025 gives us a number of 40, okay? Gives us a 40. So in order to get rid of this square root, we have to do the opposite of it. And the opposite of taking the square root of a number would be squaring that number. So if I go ahead and do that now, n would be by itself, and all I have to do is square the 40, and 40 squared, you can put it in your calculator if need be, is going to be 1,600. So how many people are in the sample? There were a total of 1,600 people that were sampled in this problem. So that'll conclude margin of error and sample proportions. And what I would like you to immediately do upon the finish of this video is to move down here below, and you'll see that there are 3 U-try problems. They are very similar to the 3 problems that I just went over with you. So please go ahead and try those out. Once you're finished, be sure to check in with me, and we'll be able to certainly go over this and look at your lesson plan for further assignments. Hope you enjoyed this video. Feel free to rewind if need be, and thanks for watching.